Today we'll be discussing on web animations and how we optimize it for performance. We have a lot of ground to cover today, but I would be going over what could benefit all of you the most. And we'll be going over some of the history of how uh, these techniques came about, and we'll be also looking at the various options we have when we try to optimize our websites for great performance. We'll also be looking at some common mistakes which developers make, and also we'll be taking a few questions at the end. So uh, hope you have them ready at the end. So let's move on. Web animations have been, crucial for several websites. If you look at all high-performing websites, which have created great value for the use cases they represent, they have all been focused on implementing very good and conscious animations which enable the user to engage with the website. So they basically create emotion, and they encourage user engagement. And if those engagement rates are high, then the conversion rates are also going to be high. And if users are able to follow with the page flow, then the business is able to succeed in presenting the idea across. So, how the website is designed and how the animations are implemented affect the turnover for every business. So, when we are taking a look at the background, animations have existed even before the web. It started with the film strip technique, which was long before the internet existed, and it was used to have people rotating across or moving across multiple cards with speed. And some of you might have done it in your childhood. You would have flipped pages of a book to create an illusion of animation by drawing consecutive frames on different pages of a book, which would give the illusion that it's animating when it's flipped quickly. So that was the beginning, but to come a long way through the web. Since most of the media is getting digitized, we have to implement something similar on the websites now in order to increase the level of engagement. So how do we reach there? So what is important when creating an animation? So animations mostly are rendered or measured with the FPS value, the FPS count. So if we could achieve the highest level of FPS which is afforded by the device, then there is a possibility that our animation is running in the optimal uh, method. But if there is a FPS drop, then there is something affecting the animation. It could be a lot of factors. We will also look at some of the factors which are affecting animations, and specifically point from the viewpoint of animations in the web, which are mostly implemented through CSS code. uh, we could use CSS animations to implement the change of state. So this method is known as tweening. So it is basically transitioning between two different values. So it could be a color change, for example, a change in color from the first color to the second color. We could create it as code. And the advantage of having this method of tracking the changes through states is that it could be reversed. We could use several features available through CSS, the CSS properties which are available to reverse the animation. And there are multiple ways in which we'll check out those as well, and how the animations can be altered. So one example of animation which is common across multiple websites is the changing of background colors. So that is something which you may have observed, and even a simple change like that requires uh, a set of stages between which the transition happens. So we could change a lot of properties which are available through CSS. We could change colors, we could change opacity, border radiuses, etc. But when selecting the property which is going to be changed, we need to be careful because some of these properties are optimized to be animated, but some of them are expensive. I'm not saying that they cannot be animated, but when they are animated, they consume a lot of system resources. So basically looking at some details into CSS animation. CSS animations are implemented through keyframes. So as you can see on the right side, there is this code. We can mention the from and the to. And as you can see, you can mention the start color and the end color. And then in the code for the div, we could mention the name of the animation. So animation name and then the animation duration. We have more properties in CSS to control how the animation works. So we'll be looking at those as well. So I'll go through a few of them which are most important and which will help you. The animation name and the animation duration, we saw it earlier. Then we have the animation timing function uh, and the delay, the iteration count, the direction, and the fill mode. So looking at all of these, I'll just show you a brief description of what they are and how they are used in the code. So the timing function, there are multiple functions available. They define the speed of the animation. The delay, it helps you a lot. You could set a delay after which the animation will start. And you could set the iteration count if you want it to repeat for a specific number of times, or you could set it as infinite, so it just keeps repeating all the time. And then there is the direction, which I mentioned earlier. So if you want the animation to go from the first state to the second state, or if you want to go it in reverse from the last state to the first state. And then there's the fill mode, which is the state which the animation maintains when it completes or when it's before it starts. So those are the basics of how animations are configured through CSS. Now, as we discussed earlier, or as we mentioned, the lower performance will be a problem if your animations have low performance. Then the UI will be janky. There will be less interaction with the user who's coming to the page, and so we need to check and look for what properties can be used to improve the performance of our animations. And we now have CSS3, which was having a lot more properties that enable smooth animations. There was a scenario when many of the animations which now exist through CSS3 was not available and had to be implemented through JavaScript. And one example is the momentum scroll. So now all of those are being incorporated into the browsers, and as newer versions of browsers are released, these features are being incorporated as well. So we have a performance which is similar to what could earlier be achieved only through JavaScript. So before we dive into what properties, CSS properties we should be using, let's look at how the browser is rendering the page. So what does it do after it gets the HTML? So as you're probably aware, browsers have certain limitations and they are not as free to use system resources as native apps. So native applications can have multiple freedoms, such as access to the system's features, which track various parameters like location and the system resources usage and the GPU. So the browsers need to load websites and load them progressively. So it's not ideal for a browser to wait for all the data to be received before showing the page. So let's take a look at what are the steps involved in the rendering path. So first, the browser collects the DOM, makes the DOM from the HTML, and then the HTML has the corresponding CSS code. So it creates the CSS object model from the CSS code. Then in the next phase, if there's any JavaScript which performs any alterations on either the DOM or the CSS object model, then it performs those alterations, and then it goes on to the render tree. So the render tree is where the different layers of rendering happen. So the style layer, the layout layer, the paint and composite. So we'll look at each of those layers and why are they important. So the initial render process. So that when it becomes available, the browser will render the page, but that's not the only time that the browser is going to render the page, because there may be parts of it which it may render later on based on different interactions which the user is making with the page. So we'll be focusing on what happens through style, layout, paint, and composite. So I've linked the references which you can explore for further reading. So in the style phase, the browser begins calculation of the styles. So this is uh, this is the phase where some of those properties are calculated which affect the layout of the page. So then the next phase, the layout phase, the browser generates the shape. So each div tag and each element of the page are generated and the positions are set so that the rendering can happen in the following phase. So several properties like width, height, margins, and the positioning properties, which are the left, top, right, and bottom, all will be set up in this phase. And once these elements are associated with the properties, then the browser begins filling the pixels for each of the elements across the layers. So these properties, such as box shadow, border radius, color, background color, all those properties would be uh, applied to the layer in the paint phase. And this phase is pretty expensive. So the properties which are being changed in this phase require CPU assistance. And then finally, we are coming to the composite phase. So this phase is the phase where it merges the layers and begins to render all the layers on the screen. And to ensure smooth animations, we have to focus on those CSS properties which are applied in this phase, in the composite phase, because the animations which are running on the composite phase properties, they can be executed on the IMPL thread. So there is this main thread, and then there's the IMPL thread. So if you're loading animations on the main thread, then they're going to directly affect the performance. But if you're loading it through a different thread and applying it on the main thread later on during the composite, then we have a smoother animation. So we'll go into this when I show you an example. We are focusing on this phase because some of these animations, if we have focus on a certain set of properties, they can be delegated to the other system resources, the GPUs. So if you if you are having, say, if you are modifying a property like opacity, then the GPU can take up the workload and reduce the impact on the processor, the main processor. So let's look at what CSS properties which we need to focus on. So these are the 4 properties which modern browsers can animate very efficiently, which is the position, the scale, transform for rotation, and opacity. So if we focus on these properties, then these animations can run on the composite layer, which we saw earlier. And once they're running on the compositor thread, we have the work assigned to the GPU. The GPU memory of the system can be used, and hence the application will be able to render more smoothly. So you will observe a higher frames per second. Then when it comes to some CSS properties which are designed to improve the user experience, such as the will change, it is effective in helping us to get a better experience, but it should be used with caution. So there is a tendency among us front-end developers to use this property in order to make things faster or smoother, but there are some caveats. So we'll look into those. So before we go there, I'll just give you a basics of what the will change property is about. So it's just specifically tells the browser ahead of time what properties and elements are likely to be manipulated. So if we have, say, suppose element which is going to change its background color, so we could mention it as will change colon background color. So that will give the browser an early indication that that property of that element is going to change ahead of time. There are other values also which it can accept. So will change auto is the default. So browser will basically apply the optimizations based on how it is programmed. Then you could give the scroll position. So uh, that means that the scroll position of that element is going to change in the near future. Or you could give contents as a value for will change, which means that the contents of that element are going to change. So we'll go over a little bit in detail. So before we go over uh, the places where we need to be careful, I would like to get some inputs from the audience as well regarding which is the correct application of will change property. I'll be looking at the chat. So is it option one or is it option number two? It's an audience question. Anyone can answer. If you're not able to answer on mute, you can drop your option in the chat as well. Let's make this interactive. I don't see any answers. Anyone with the, I mean, it's fine. Even if it goes wrong, we can, there's no harm. You can, okay, I don't see anybody coming up with answers for these. So you can select if it's either the first one or the second one. Uh, yeah, some answers are coming in. Awesome. I mean, it's pretty simple for everyone. I feel that, uh, developers, you should be knowing this. Okay, so I'll give you 4 more seconds, and after that, I will reveal the answer. Everyone else who is going to post your answers, please do it quick. Okay, 3 more seconds. 2, 1. Okay. All right. So let's go on. The answer is the first one is the right one. So the reason why we are adding the will change to the A tag, to the A within outside of the hover and outside of the focus is because we want to inform the browser ahead of time that the color of the anchor tag is going to change on hover and focus. So we should avoid mentioning the will change within the hover and focus. Instead, we should mention it within the anchor tag definition itself. So that will help the browser to optimize better. And there is a negative effect of using will change globally. So recently, I ran into a situation where I had used will change in one of the styles for some of the elements in the web page, and it was rendering with a different color. It could not match the design. So we tried changing the colors first, thinking that that was the reason we added opacity, but we didn't realize that the color was being impacted by will change. So once we removed that, it was rendering fine. So you need to use this with caution. You should not use it for anything and everything. Also, do not use it in a global state. Don't use it with a star so that it affects each and every element. Try to be specific with what is going to change, through will change. And there is a recommendation. Mozilla recommends that you add this will change property to elements uh, just before the animation, and remove it after the animation is completed. So you can see this JavaScript code which is doing that. So we are creating an event listener for the mouse enter, and we are creating a listener for the animation end. So add will change will add that will change property, and the remove change will set it to auto. So that is the default setting. So this enables the browser to have the will change property set based on the most optimal way it can handle. So this is going to improve your page performance. So moving on, let's look at how we can implement hardware acceleration. There are some methods, as I mentioned earlier. The will change is useful for informing the browser ahead of time, but also if there are some cases where we want to have higher level of resources made available by the system, you could add transform translate 3D with basically a null 3D animation. So the system automatically designates it to the GPU resources which are available. But you also have to keep in mind that there's a tendency for higher RAM usage if you're using this. So this will make your animation smoother, but you also need to know that it's going to take up higher levels of RAM. So this is one example. And then we'll also explore a few tips on how we could optimize for performance of animations in general. So as we discussed earlier, we should avoid changing any other properties other than opacity and transform, because those properties other than that, such as the border radius, the width and height, all of them are going to be implemented in the layout phase of the rendering pipeline, which is more expensive. So each time if you change one of those properties, the browser will have to go through that layout phase again, consume more resources. So instead of changing the width or height, you could use something like transform scale, which will enlarge the element based on your requirement. Then the next tip is try to conceal content in plain view. So when we have properties such as pointer events and opacity available, so we could use those to essentially make those objects which are being animated as inaccessible to the user if they are using the mouse. So that would reduce the level of computation associated with those elements which are going through an animation. So once the animation completes, you could remove these properties. You could remove the pointer events, or you could set it back to opacity 1 so that it's completely visible. Then the next step is not to animate everything at the same time. So we need the animations to run in cohesion. In particularly, when I'm introducing this term like choreography, it's basically setting a delay or setting an order for all of those elements to appear in the scene, but they appear in such a way that it feels like a well-designed unit. So it should not appear as a disconnected you know animation where each element is coming from one or the other place, but it's not feeling like a complete unit. So there is a lot of fine tuning involved in it, and we may have to adjust for the delays and the timing, the animation timing, and make these properly included in the keyframe so that it appears as a single unit. And why is choreography so important? Because if choreography is not performed in the correct way, then there are other issues which could also affect the performance of the animation, such as network lag, or there are some other scripts running for analytics or ads. So those things are going to take system resources away. So if you're not timing your animation correctly, and if you're not staggering it correctly, then there is a chance that the animation would look a bit disconnected. So how you can capture this is, once your animation is running, you could effectively do a screen recording so that you could play the recording in slow motion and then see that certain parts of the animation are not getting timed correctly. They are not coming into the picture at the right time. So those are some of those ways in which we can improve the animation. Now coming to measurement, how can we measure the performance? So I'm pretty sure most of you are using Chrome and you're familiar with Chrome DevTools. So DevTools has a performance panel, and we look at how we can use the performance panel to analyze the performance of our web page. Okay, so uh, Let's take a look at the demo. Okay, so here we have a bunch of tags, image tags. Okay, and you can see that all of them are having two values set on them. So the first is the top value, which is a CSS property which is determining the distance from the top, and there is a left value, but we are not animating the left value for this animation, but we will be animating these images for their top values. So as the top value changes, these images are going to bounce between these two edges of the viewport, and you can see that they are, you can see the frames per second. Okay, so let me pull out the frames per second as well. So let's look at the frame rendering stats. So what we should aim for is 60 FPS. So I'll just start the animation right now. So as you can see, it goes to 60, but it's also dropping below 60. So what if we could add a few more animating elements? Okay, so let me add 10 more. So now we have 20 elements. As you can see, the frames have started dropping. If I keep on adding in this manner, the frames are dropping pretty quick. And as you can see, the top value is changing for all these elements. So the top CSS property, as we mentioned, as we discussed earlier, is the property which is being applied at the layout phase. Okay, so it requires uh, this browser to repaint and recreate the layout, which is an expensive CPU operation. So how about we target a CSS property which works on the composite layer? So one example of that is the transform. The transform CSS property works on the composite layer. So let's try animating the transform property. So as you can see over here, the transform property is now not changing, it's at 0, but I will optimize it so that the transform property is now being changed instead of the top. So top is now all zeros, but we are changing the translate Y so that the results are seen visibly. So you can see the frame rate has gone back up to 60 FPS, and everything seems to be smooth again, even though we have now got 50 elements animating. So that's the reason why it's important to select the right CSS property when you're doing your animation. If you're targeting a CSS property which is working on the layout phase of the rendering pipeline, then you're going to lose performance. But if you're targeting a CSS property which works in the composite phase, you're going to gain a lot of performance. And the same applies to mobile as well. Okay, so let me pull up the mobile version for you as well. So as you can see on the screen, I've just mirrored my phone. And if you look at the animation, you can see it's dropped well below 60. It's lesser than 50 for just 10 elements which are animating on the screen. So if I keep adding more elements to this, the performance is going to drop particularly. Mobile processors are not capable of handling it, and therefore, if I now switch to using the transform property, so now the property which is changing is the top CSS property, which is going to reduce the performance. But if I'm going to use the transform CSS property, which works on the composite layer, then I get a higher FPS. So as you can see, my FPS has climbed up. It's gone back up to 45. So that's what I'm saying. It's like the conclusion of the matter is like, it's really, really important to have the right CSS property being used. Otherwise, it's going to affect your desktop performance, and it's going to be an even worse situation when it comes to mobile performance. So how do we record performance? It's also possible to record the performance of your website. You can create a performance profile with the Chrome DevTools, and this was the performance profile that I recorded for the page that you just saw. So I recorded for 4 seconds, and as you can see the performance profile when you're recording it, there are a lot of areas in this graph which are coming up as red. So those areas include indicate that there is a high FPS drop, and that is not what you want. So when I change the property from top to translate y, which is the transform property, then you can see that the red areas have disappeared, and now we have very high FPS. We have close to 60 FPS coming in, and that is exactly what we want to target.